Okay, so we are skipping from section 4.6. We're jumping 5 sections to section 4.11, but I think this is going to benefit us when we do section 4.9 because you already have a little bit of understanding of what a complex number is, okay? So we're going to be simplifying complex numbers first, and then we're going to graph them. Graphing them is super easy. It's just like plotting points. Very simple. You're not going to be drawing like curves or anything like that. So graphing them is not that big a deal. Simplifying them also not too big a deal. You've already known how to simplify like terms. That's pretty much what this is like, okay? Just doing like terms. So first off, let's define what a complex number is, okay? So let me put this right here, complex numbers. And I'm going to put right here standard form, because there is a standard way to write it. It's not a hard thing. It's literally, I guess I could put plus or minus there. It's 3 letters. That's it. That's your standard form of a complex number. Okay. The I is called the imaginary unit, and I'll write it down right now. But the I is called the imaginary unit, and then you have an A and a B term. Well, A and B are basically X and Y. All right, remember that, okay? A and B are basically X and Y. So whatever the number is for A, that's your X value. Whatever the number is for B, that's your Y value, okay? Remember that. I'll remind you later because that's what's going to make graphing super easy because it's just like graphing a point. But A and B are basically your X and Y, all right? So I'll put it down right now as we go through some of this, but let me just write down this right here. I is your imaginary unit. Okay, I is equal to the square root of -1. So remember how they always told you like you can't have a negative number inside of a square root because it's not going to work, right? The reason why it doesn't work is because its value is imaginary. Square root of -1 is an I, okay? And imaginary units, we don't really use them in real life, but we do tend to use them in space travel and stuff like that. So in order to get out of our atmosphere, we need these type of numbers, okay? But that is its value. Now, I'm going to give you one more thing about I. If you ever see I squared, that's -1. Because you basically square the square root. That removes it, right? So I squared is -1. All right? Now, one more little like hint, like I said. A and B, you can write them as points, X, Y. All right? So A plus or minus BI, the plus or minus pertains to the B value. Okay, so maybe it's A plus B or maybe it's A minus B. But the B value gets the positive or negative sign. Sometimes the A value will have one as well, but most of the time in standard form it's just the B value. So you're just going to basically write your A plus or minus BI as A comma B, and then that basically is supposed to be your point XY. Right? And again, we'll see more of that when we get to the graphing part. All right. Right now, most importantly, for the first examples that we're going to do, this is what you have to remember. Okay. For what we're about to do right now, it's that the I squared definition more importantly than anything. Okay. But remember that. Right now, we'll get to it and do some examples. I have like 6 examples we're going to do really quick, and they don't take long. Okay. They don't take long. So, but again, A plus or minus BI is called your complex number. I is your imaginary unit, okay? I is equal to the square root of -1. If you square I, you get -1. And don't forget that your A and your B terms, again, A and B can be positive or negative, but don't forget that your A and B terms, if you write them as a point, they translate to a point as XY, okay? So we'll get to that part later. But here's the first part. The whole front of your homework is going to look like this. So example number 1, we're just going to simplify. We're not solving anything. We're just simplifying. Actually, let me write part A, I guess, makes more sense here. So 2I times -6I. Now, whenever you multiply complex numbers, things with the letter I in it and stuff like that, you're going to do it like this. Numbers first, then the I term second. Okay? So 2 times negative 6, well, that's negative 12. I times I, that's I squared. But what's I squared? Negative 1. So 12 times negative 1. So your answer is 12. That's it. Okay? That's all you have to do for that one. Just simplify it. Okay, simplify it. Sometimes all the I values disappear. Sometimes there's a couple left over. We'll see. All right? So that was not too bad, right? So what about something like this? Now we're going to get 3i and we're going to add negative 8i. Again, find your like terms. These are both like terms, right? Because they both have an I there. Deal with your numbers first, right? So we have the 3i plus negative 8i. Think of it like an x. If it was 3x plus negative 8x, right? Just because it's an I doesn't make it different. It does have a different meaning in the end, but just think of it as a variable. So what's 3i plus a negative 8i? Negative 5i. And that's it. You're done. Right? All right. So again, it's called complex numbers, but doing the work isn't that complex. Okay, it can get a little bit more complicated, but it's mostly just the way the problems are written. But let me give you another one. I said we're going to do like 6 variations of this. That way you can see all the types of stuff you're going to see in your homework. Here's the next one. So part C, the quantity 4i squared. So 4i squared. Well, what's 4 squared? 16. And what's I squared? Well, negative 1. I'm going to write it first I squared, but that is negative 1, right? So my answer is negative 16. What do you guys think so far? Not a bad deal so far, hopefully, right? Let's add in some multiplication here where we're going to have to distribute. Let's do that. This is when you're going to start seeing that there's going to be some numbers and some i's left over. But it doesn't make it more complicated. It just means you got to do a little bit more work. But the main idea is still look for I squareds. If not, just combine like terms. So for this one, we're going to be doing multiplication by distribution. Okay, so I am going to multiply 3 times 6 and 3 times 2i first. So let me do that. So 3 times 6 is 18. 3 times 2i is 6i. And then I'm going to multiply negative I times 6 and negative I times 2i. So negative I times 6 is negative 6i. And negative I times a positive 2i is a negative 2i squared. Right? So notice 6i minus 6i is going to cancel, right? This is going to actually cancel out. And then I have negative 18 minus 2 times negative 1, right? Because I squared is just negative 1. So that's really a plus 2. So 18 plus 2, that's 20. And there we go. Any questions on these two? All right. So that's part D. Let's go to another one. Let's see. So this one looks kind of long, but again, just kind of treat it the way you would if you're going to be combining terms. This one actually is a homework problem, just so you guys know. The other ones are that I've done so far are not. Okay? But this one is a homework problem. So the first thing you want to do is just kind of simplify this thing, right? Like distribute the negatives and stuff like that. Get rid of all the parentheses. So I'm going to start off with the left, on the left side, I'm going to write negative 4 plus 6i minus 3 minus 3i plus 3 minus 4i. Notice the only ones that changed sign was the middle terms because those have a minus in front of the parentheses, so you have to distribute it. Okay? But when there's a plus in front of the parentheses, it doesn't change anything. Now just join your like terms, okay? So if I join my like terms, let me highlight my like terms. Negative 4 is a like term with negative 3, which is also a like term with positive 3. So negative 4 minus 3 plus 3, that's negative 4. And then my other like terms are the I terms. So the 6i minus 3i minus 4i. So what's 6i minus 3i? That's going to give me 3i. And then if I subtract 4i, negative 1i, right? So negative I. And notice, I'm not going to make that I into negative 1 because it's not I squared. And I'm also not going to rewrite it as the square root of negative 1. I'm just going to leave it like that. Okay? So there you go. There's that one. Again, notice the stuff that we're doing, the skills that we're using for this is nothing that you've never done before. We've combined like terms. We've multiplied binomials together. We've raised numbers to powers, right? We've done all that stuff before. So this isn't like, oh my gosh, I've never seen so many parentheses before. We have. We've done this before, okay? So hopefully that's not going to scare you. It's just that now we have, instead of x's and y's and a's and b's, we're using the imaginary unit, I. That doesn't really change anything unless I becomes squared. If I becomes squared, then you have to write negative 1, okay? Whereas if x became squared, we just left it x squared, right? If it becomes squared, you got to change it. So, all right. Here's one last one of these, and then we're going to do the graphing portion, which I think, I don't think is going to be much more difficult than this. You guys might actually appreciate it. You might like it because it's pretty straightforward. But here's the last one. So I know we've done some like this already, it just didn't look like this, but 2 minus I quantity squared basically means that there's two of those things that multiply together, right? So first you're going to want to rewrite it. You're going to want to rewrite it as 2 minus I times 2 minus I. Okay? And then you're going to want to distribute it. All right, so I'm going to start with the 2's first. So 2 times 2 is 4, and 2 times negative I is negative 2I. And now I'm going to go with the negative I, the second term. So negative I times 2, negative I times negative I. I'm going to multiply those together. So negative I times 2 is negative 2I, and negative I times negative I is a positive I squared. Now let me simplify a little bit. The 4 is there. Negative 2I minus 2I is negative 4I. And then I squared is a minus 1. So notice it's plus a negative 1, so I put minus 1. 4 minus 1 is 3, so I'm going to write 3 minus 4I, and that's my answer. All right, so there's 6 examples of what you guys are going to see on your homework. And I think there's a total of 9 problems that you're going to do that are like that, okay? So there's about 9 problems that you're going to do that are similar to this stuff, whether you're multiplying, adding, subtracting, simplifying, but they're going to be like that, okay? So that's the simplification. Do you guys have any questions on these? A, B, C, D, E, or F? So I think the hardest one to me, honestly, is this one because it looks really busy, right? I think for most people that'll be the hardest one. Even though it's not considered to be a hard problem, this one's actually considered to be tougher, okay? But I just think this one looks so busy that it can mix people up. So Just take your time with it. Don't rush it. Okay? All right, so let's go to the graphing portion. All right, so when we do the graphing, let me just double check on the instructions. I have certain things, but I want to make sure. All right. When it comes down to the graphing, you guys have to know how to rewrite a complex number into a point. So let me put that right here. Complex number to a point. Okay? So a complex number to a point. I'm just going to give you a couple of written out examples. If you have 2 plus negative 3i, that becomes 2 comma negative 3. And vice versa, okay? If they give you a point and they want you to write it as a complex number, that's the way you write it, from right to left. Okay? So 2 plus 3i. I'm sorry, I just realized I was supposed to write 2 minus 3i. I'm sorry. Can you guys erase that, fix that on the left side? It's supposed to be a minus. I'm going to make it green so you guys see the change. It's supposed to be 2 minus 3i. So that's going to be 2 comma negative 3. Okay? And if they give you a point, you can write it backwards. So if I were to give you, let's say, negative 1 plus 6i, then you should write it as a point negative 1 comma 6. Okay? What if I gave you a point, let's say 4 comma negative 1? How do I write that as a complex number? 4 minus I or 4 minus 1i, either way works just fine. But there you go. Okay, that's how you translate it, okay? From a complex number to a point, or from a point to a complex number, okay? Either way works the same. So, this is what they're going to be doing. And you have 4 graphing problems, okay? The first 2, they're going to ask you to graph the point. So here we go. So example number 2. And I'm going to do 2 of them, but on the same graph, okay? I'm going to do 2 of these on the same graph. The first one I want us to graph is 2 plus, let's say 2 plus I. And then the next one that I want to graph is negative 3 minus 4i. Now you're just going to have to do one of these per graph, and the graphs are already provided for you, so you don't have to worry about drawing them all out on your homework, but obviously in the notes you kind of do. So the first thing I would like you to do, not that you have to, but the first thing that I would like you to do is rewrite each one of these as a point. Okay? So 2 plus I, what does that translate to as a point? Not 2, it's 2 and then plus I, so positive one. Remember, when I did the example, I messed up the first one, right here. 2 minus 3i. I was supposed to write 2 minus 3i, but I accidentally put 2 plus 3i. So if that confused you, I apologize for that. But the signs follow it, okay? Whatever's on the signs, it follows. So that would be a 2, 1, right? And what's the next point right here? Negative 3, negative 4. So I'm just going to graph these like I would normally graph any point. 2 comma 1 is right here. I'm going to call that A, because that's part A. And negative 3, negative 4 will be right here, and I'll call that B. And you're done. You graphed them. That's how you graph complex numbers. Okay? So just so you know, we normally call this the x-axis and the y-axis, right? When you're dealing with complex numbers, treat it like that. But this is actually called the real axis and the imaginary. Okay? Because remember, the b term, this part right here, the 1, the b term, is part of your imaginary unit. Okay? So that becomes your y value. So your y value is the imaginary axis. Your x value is the real number, a 2, a 5, a negative 3. So those are real numbers, so that's why they call it the real. So they'll call it the real and the imaginary, okay? But it's still x and y. Okay, don't let it like confuse you. It's x and y. That's all it is. Okay? And just treat it like that. Now, for example 3, I'm just going to do the opposite. I'm going to give you a picture. I'm going to put 2 points there. And I want you to give me the complex number that represents it. Okay? And then we're done. So, here we go. Example number 3. Write the complex number that is graphed. Write the complex number that's graphed. All right, so here we go. Let me graph a couple of them here. And one of them is going to be kind of tricky. Let's see. Let's see if you guys get it. I think you can do it. It's going to be a little weird. All right, so I'm going to call it, we'll go with A. Or let me do lowercase a. We'll do B, C, and D. Now, I would recommend that you guys write it as a normal point first and then translate. But you don't have to, okay? You can just give me the complex answer, and there you go. But I always tell people, like, just to make sure, give me the point first, the way it looks, X, Y, right? And then we'll translate it over. I'm going to write real and imaginary here just to kind of get you guys used to seeing it, because you might see it on tests. Again, you can call it X, Y, it's fine. Nothing wrong with that. But they just like to label it the real and the imaginary when you deal with imaginary numbers. All right, so can you guys give me the actual point for A first? -4, 2. That translates into what? -4 plus 2i. There you go. Done. Okay, so that one's done. All right. B, what is that point? Hold on. 2, -5, right? Yeah, 2, -5. Thank you. And that translates to 2, -5i, right? 2 minus 5i. All right. Now for some that are a little tricky. Not terrible, but what's the point for part C? 4,0. So if I translate that into a complex number, what is it? Just 4. You could put 4 plus 0i, but 0 times I is 0. There's nothing there, right? So it's just 4. That's it. Again, there's nothing wrong with writing 4 plus 0i. It just may not be an option on a quiz if you see it, because they're going to be like, well, 0 times square root of -1 is 0, so it doesn't have to be there. And what about D? What is that point? 0, 5, and that translates to 5i. There you go. And this is your homework.